Number 8, find the values of x at which the function has a possible relative maximum or minimum. So possible relative maximums or minimums, that's like code for saying find the critical points. So we will stop and take a derivative. This looks like a product rule. I have 1 plus x as one thing, and then the other part is e to the negative 3x. So derivative be, let's see, the derivative of the first times the second plus the first times the derivative of the second, which is, let's see, derivative of 1 is 0, derivative of x is 1. So 1 times e to the 3x, or just e to the 3x would have worked. And then plus 1 plus x times the derivative of e to the 3x, which is e to the 3x, times the derivative of 3x, which is just 3. So I have e to the 3x plus 1 plus x times 3 e to the 3x, or e to the 3x. See, I could factor that out. If I factored e to the 3x out from everything, I'd get a 1 plus 3 times 1 plus x. Actually, that does work, but it's probably pretty confusing. I think it would be easier to multiply out. That would make more sense. Okay, so if I multiply these out, I would get 3e to the 3x, and then plus 3x e to the 3x. So if I factor out e to the 3x, I'm left with something pretty easy. So e to the 3x, and then, let's see, 1 plus 3, right, these two would combine, plus 3x. Okay, and in the last video I mentioned that we're setting this equal to 0 because it's a critical point, but e to the 3x is never going to equal 0, so I actually can ignore that and just set the other part, 4 plus 3x, equal to 0. And that would be 3x is equal to negative 4, x equals negative 4/3. So that's my possible relative maximum or minimum. Okay, let's do B. Same idea. If I'm going to find a possible relative minimum or maximum, I need to find the critical points, and I would do that by taking a derivative and looking to see where it's not defined or where it's equal to 0. Okay, so 5x minus 2 e to the 1 minus 2x. So I would do the derivative of the first times the second, and then plus the first times the derivative of the second. So derivative of 5x minus 2, that's just 5. 5e to the 1 minus 2x plus 5x e to the 1 minus 2x minus 2e to the 1 minus 2x. So I have a 5e to the 1 minus 2x minus 2e to the 1 minus 2x that I can combine to just be 3e to the 1 minus 2x plus 5x e to the 1 minus 2x. And again, I can factor out e to the 1 minus 2x, and that's 3 plus 5x. And I'm looking to see where this is 0 or not defined. And normally what I would do is I would solve each of these individually. E to the 1 minus 2x equals 0, and 3 plus 5x equals 0. The only thing is e to a power is never going to equal 0, so I don't even need to borrow with that one. I don't need to bother with that one. But I will solve this one, 3 plus 5x, by subtracting 3. And then dividing by 5, I get x equals negative 3 over 5. It's pretty nice. Okay, and we'll stop here for questions.